Good evening, welcome to Space Oddities. Sorry about the false start there, we had a slight technical issue, but I think we're back online now. Good evening, thank you for joining us, and welcome to Space Oddities. If this is your first time here, it's great to see you. And we'd also, first of all, like to say a big thank you to those of you who joined us for the live coverage yesterday of ULA's Vulcan launch yesterday morning. The launch went very well indeed, flawless launch of a new rocket from ULA. But as you may have seen in the news, the astrobotics lander that it was carrying or launching to the moon has suffered some major problems, but we will talk about that later. On a packed show tonight, I'm joined by some usual suspects. So we got Daz. How are you, Daz?
Lovely, thank you. Can you hear me?
Unfortunately, yes.
Can you? Well, you know,
we have to bear. So there you are.
Yeah. Oh, we're lovely, thank you. It's a bit cold here today.
It's a bit cold here as well. At least it's sunny.
Yeah. Well, it's always sunny in Spain, isn't it?
Well, more or less.
Because the rain falls on the plane.
It does, you know. And my wife went for years thinking that it was Plane. She could never work it out. But there we are. I'm also joined by Mr. Roger Hyman from darkest Somerset.
That's because it's got clear skies.
Right. That's where it always seems to be clear.
No.
So welcome, Roger.
Hello.
Michael, how are you?
Okay, thank you. No.
Yes.
Ready to go.
Excellent. From the United States, Mr. Lou Mayo. How are you, Lou?
Greetings. I'm just wringing my hands that I spent all this money on an observatory and telescopes and mounts, and my friends are turning out better pictures than I am with a $500 Sea Star.
Yeah.
Yeah, that telescope is really making a name for itself, isn't it?
It is actually. Yeah.
I see Celestron have just bought out a new Wonder telescope as well.
Yeah, 6-inch for $4,000 US dollars.
Yeah. I'll have to save up my my Amazon tokens for that. The technology is coming on amazingly with all these new robotic scopes. So there we are. Anyway, last but certainly never, ever, ever least, we have the lovely Rachel. How are you, lovely Rachel?
I'm good, thank you.
And how's little Isaac?
He is still awake. It's a late bedtime today, 10 o'clock. I don't know how I'm going to stay up that late.
Oh, well, never mind. Thank you for being with us and leaving little Isaac. So, what have we got for you tonight? Well, tonight on the show, we've got a bit of a mixed bag. We're going to look at the news. We're going to see what's been going on in the world of astronomy and space exploration recently. We're going to have a look at the subject of planetary defense, defending the Earth from asteroids. Lou's going to talk to us about angular resolution, and if you're not sure what that is, all will be revealed. And what else have we got? We've got a couple of other things as well. We're going to finish off the review that we started last week of big events in 2023. So there's a lot to look forward to today. But as always, we're going to start in time-honored fashion with Roger. So, Roger, what's up in the sky?
Well, lots of things, because I'm doing M78 at the moment. So I've got my laptop doing a live preview as I speak. So, January, nearly halfway through the month already. We do have a new moon on Thursday, so there's still clear skies. Get out there. And this was one of my better waning crescents that was a few mornings ago. Anything after this, there's not much detail, so I don't really bother. So
that's
there
wonderful.
we go.
Another winner.
But, that one did come out rather nicely. Thank you.
Yeah.
Right. Okay. So looking due south at 10 o'clock through this week, we have Orion gracing the skies in all its splendor. And we still have Jupiter reasonably high up in the sky. Saturn has now set at this point of the night. And we will be seeing Leo come up with all those galaxies and stuff. So, but at the moment, we're gladly admiring the great constellation of Orion. So, looking due south, you can see the great objects that there are there. And there will be some notes to be mentioned about that shortly.
Fantastic.
Okay, so as we progress through, and in the morning we've got Venus, and shortly after that we've got Mercury, but that one will become a bit difficult because it is quite low to the horizon.
It is, isn't it? Yeah.
And we've got the sunrise to compensate. But following on from that, we've got not only Mercury, we've got Mars as well. So that can be.
It'd be good to have Mars back in the sky.
Yeah, but later in this month, there's quite a good conjunction of Mercury and Mars together in the morning sky. But it will be a bit of a challenge because it will be very low down on the horizon. And, getting nearer to those earlier sunrises. But we still have some comets of interest. In Cygnus, we got Pons Brooks coming through. So that's working out quite nicely at the moment, although Cygnus is setting into the sky, and it's not a bad brightness. It is visible with binoculars or a small telescope. That gives you an idea of roughly between 8, and it actually is getting brighter as it goes through January.
Right.
But going through the constellation of Taurus, we've got Comet 144P Kushida. And that would make a very good picture on the 10th/11th of January, where it is quite close to Aldebaran. So a little bit of a photobomb. So according to this, it'll probably be about 10 o'clock on the 10th of February, 10 p.m. on there. So might be.
Is that UK time?
That is UK time. Yes.
Right.
Sparkford time.
Sparkford time. The only time that matters.
Yep. And as you can see from this, it is a much fainter, like 5 magnitudes fainter than Comet Pons Brooks. So it might be a bit of a challenge, but if it's going to be got, it could be a good opportunity to get another comet, which will be quite high up. So it's got the help with that.
Right.
And that's all I've got, I'm afraid. Short and sweet,
but to
the point.
Thank you very much indeed. That's wonderful.
Andy, can I just pop on just quickly? Anybody watching on Facebook, like Derek said he was, you can chat to us. We will see it in the restream chat, but of course it won't appear on the YouTube. So if you still want to chat to us, just pop in some text and all that and send it to us. Just put your name at the end so we know it's you, because you'll come up as Facebook user otherwise. So you can talk to us, but you just won't be on YouTube. I just thought I'd better point that out.
Yeah. Thanks for pointing that out, Daz. Yes, if you would like to chat to us on Facebook, as Daz said, make sure you give us your name, because to us, you just appear as Facebook user, because Facebook doesn't transmit the name of the user, unfortunately. So there we are. And Dave says he currently has 33 times 2-minute images of Flame and the Horsehead nebulas. We'd love to see them, Dave, wouldn't we?
Yeah, we certainly would.
So pop them in an email to us, Dave, and they'll appear in the gallery. That is,
once you process them.
Oh yeah, obviously. Yes.
We don't want 32.
Yeah. Yes. If any of you would like to send us your images for the gallery, then pop them in an email. 1 image per email, please, to spaceodditieslive@gmail.com. spaceodditieslive@gmail.com, and we will feature them in the gallery with pleasure. So there we are, and there'll be a link. There we are, and Rachel's just popped up a link to that in the chat. So there we are. Okay. Well, talking of Rachel, Rachel is now going to show us the delights of one of our favourite bits of the week, looking at your images that you've sent in. So, Rachel, are you ready?
I am ready as ever.
Okay, so there we are.
Okay. It's another short and sweet gallery this week, but still high quality nevertheless. So again, we're kicking off with Jerry, the regular. I think he's beating Chris O'Riordan and Kev now with the amount he's submitting. He's a busy, busy man.
It must be close.
With the California Nebula. And well, yeah, I think he said he's processed and joined these together, so it's a 2-pane mosaic of images which he's stitched
Ooh.
together.
Hey,
That's
Wow.
pretty good.
That is superb.
Beautiful.
Whoa.
Another winner, Jerry. Thank you so much.
Well done, Jerry.
That's
Big.
really 3D, isn't it? It's
Yeah,
amazing.
it's got lots of depth to this one. It's like a crashing wave. It's beautiful.
Mm.
Absolutely.
But Jerry did not rest. And this one, I did look. It took me a while. I stared at this email for a long time because it was titled "Animals in the Rosette Nebula?" ?
Oh,
But he didn't actually
I
highlight.
see a jumping dog there on the right.
Yeah, absolutely. Yeah.
So I
It
don't know.
looks
I'm
like
looking in the dark
Can I not see a deer down below the jumping dog coming towards us?
Oh yeah. Yeah.
Oh, yeah.
Walks right in towards us. Yeah.
So we're looking at the dark structures, aren't we?
Yes.
Yeah. The dark lanes.
I can see the deer,
dust.
I think, and
Yeah.
maybe the jumping
It's
dog.
a jump.
Yeah.
Is
The
that, the
I see a fox as well.
is that the animals from the dark side, is it?
Yeah.
Because you mentioned this, and of course we talk about cosmology. Well, some of the South American peoples, they actually see animals in the Milky Way, and it's quite interesting to see them. They got things like llamas,
A lot of alpaca llamas, and is it a peacock? I want to say a peacock.
well, possibly, yeah. There's a whole load of animals, and there's animals stalking other animals, and it's quite like I said, when we do the cosmology, and this is why I think everybody finds Karim's talk so very interesting, is that it's a different view from a different people about the same thing that we're looking at. So yeah, it's fantastic.
Well,
Sorry, I
there's a
just
stone, isn't there, in the middle of? Is it the Atacama Desert? Is it a petroglyph or something? It's got the markings on it and of what they depicted to be the Venus and the Milky Way, and there's quite a lot of llama shapes drawn on there as well.
Yeah, absolutely. Yeah, it's amazing.
So thank you for that entertainment, Jerry.
Yeah, that's brilliant. Definitely looks back there.
Then Sonia's been busy with her Sea Star, which again I think she got this submitted. I can't remember which news channel, but it was shown. And this is 45 minutes of stacking on the Andromeda Galaxy, and she thinks this is her best image yet.
That's fantastic.
That's
a
an
Sea
amazing
Star image.
Yeah.
Sea Star, yeah.
I give up.
Yeah, see what yeah,
That's gorgeous.
yeah. Lou's favourite equipment, that is.
Yeah.
Yeah.
Where's
Yeah,
my
I'm
check?
excited because my friend has just bought one today, and I'm seeing him in a few weeks, so hopefully we'll get to at least have a play, see what it's like. So yeah,
Yeah, I
thank
must
you.
start
Well done,
checking
Sonia.
my emails because I've got some notifications for Sea Stars when they come into stock because they're so popular now. But I don't check my emails, so I keep missing it.
And there will be a review of the Sea Star S50 in the next FAS newsletter.
Right.
Ooh.
Yeah.
And
Apparently,
if any
Rother
of you,
Valley Optics have them in stock today, so
Oh, right. Okay, then I'm off. Bye.
have a look.
yeah. If any of you viewers would like to do a review of the Sea Star, or indeed any other equipment,
Yeah.
do it in a video. You can do it on your mobile if you like, however you want to do it, and send it to us, and we can feature your review. And whatever it is, we're always more than happy to accept submissions from our viewers. So give it some thought. If there's anything you want to talk about or anything you want to review, then do it, and we'll show it with pleasure.
They are in stock at the widescreen centre.
Okay, then we'll find one somewhere.
Cool. Moving on with the Sun again by Sonia with the Sea Star, which I'm guessing it's taken today because she said it's a very busy sun today.
Yeah.
All right.
Yeah,
because we were talking about sunspots a week or so ago, and I said I was waiting for December's results to be added, and the sunspot count is going up again. So we could be going into maybe a double peak, but it's unpredictable. But it's interesting to watch.
Yeah, definitely.
I mean, there's
Well
plenty
done,
there.
Sonia. That's fantastic. Thank you.
Well done. And then Andy has sent one, and he said this is his first proper attempt at Alnitak with the Flame Nebula and the Horsehead. which he took from Gresham Observatory with a Canon 6D. And this is one single 7-minute exposure. So the detail for one
Wow.
For
shot
one
is
shot.
incredible.
Oh
But
my goodness me!
Oh,
Wow.
wow.
Yikes.
That is fantastic.
so obviously,
There we are.
Andy, I'll just say a little bit more. He said he took this at Gresham Observatory. Now, Gresham Observatory is a really cool observatory, obviously, in Middleton Teesdale. And it's got, obviously, you can see on the bottom right, it's got a classroom where you can have a talk, and they've got a load of dobs that they get out for the public to use, and they do loads of sessions. They regularly get aurora around there, and it's in such a good location because it's almost in a bowl, if you will, so it just shields that tiny bit of surrounding light pollution, so you just get these inky black skies. So you should definitely, if not, follow them on Twitter or X, if we're calling it, but go ahead and have a look because they do some really good family sessions and aurora nights and all sorts of good gear.
Yeah, because you can see the lights just above the first ridge. There's obviously a town the other side of there, and that seems to have cut it all out as well.
It's just sort of near. It's right on Gresham Reservoir, so it's not far from Barnard Castle. But it's a really lovely. They're in some sort of weird microclimate because we drive up, and I've been, over 20 times now, and we've driven up in hail and just torrential rain. And you get there, and you get in, you do the talk, and you come out, and it's just clear. It's just inky black and crystal clear.
Wow.
And they always get really lucky with the weather.
Yeah, it's Sparkford up north, isn't it? Up to north.
Yeah.
So
that's right.
definitely go and have a look and get yourself booked in if you are, even if you're not close by, it's worth a travel. So
Yeah, and that's www.grasholmeobservatory.com. Check it out. Give them your support. Give them your love.
And that is it for me.
Right. Thank you so much. That's fantastic. Well, thank you all so much for all your images. Yet again, as you know, it's one of our favourite parts of the week. We do love seeing what you send in. And don't forget, as I said, if you'd like to review any equipment, do it in a video. You can do it on your mobile. We're not fussy. And tell us what you've got and talk about it. Okay, right. Well, we'll move on then. So I think now it's time to have a look at the news. And there's been quite a bit of interesting news recently. So let's have a look all about it. So what have we got for the news? Well, the first thing we've got for the news, just let me sort myself out here, is the launch of the Vulcan rocket, this brand new rocket from United Launch Alliance on which so much depends, and a very important launch for not just ULA, but for the whole of the satellite launcher industry. And this happened yesterday morning. Again, thank you for those of you who joined us for our live coverage yesterday morning. The launch itself was picture perfect. Everything seemed to go exactly to plan. And just one second. What's this thing doing? So the launch itself went perfectly to plan. And we watched as that brand new rocket that nobody's seen launched before sailed into the sky. Some lovely images of that. But as we know now, there was a problem with the astrobotic lander that the ULA Vulcan Centaur was sending to the moon. It appears to have suffered some sort of fuel leak, which meant that it couldn't power itself to turn its solar panels towards the sun. The team came up with a fix for that, and when it came out of radio silence, which was expected, they determined that the batteries were charging from the sun, but there was, as I said, this major problem which looks like a big fuel leak. The lander is now not expected to get as far as the moon. It's got enough battery power for the next 40 hours, roughly. They're trying to configure it to do some sort of science, but basically it's not going to land on the moon, which is a big, big setback for astrobotics, a big setback for NASA, who got 5 experiments on it, and a big setback for the 7 countries that also had payloads of one sort or another on this lander. It was the first lander in NASA's commercial lunar payload service, by which NASA have been encouraging private companies to send payloads to the moon. It would have been the first moon landing by NASA, including astrobotics, of course, since Apollo. And it's a real shame that the mission now seems to have failed. What exactly caused the fuel leak, we don't know. This is a view from the astrobotics lander. In the foreground, you see what's called the MLI, the multi-layer insulation. You can see, I think, that there's a problem with it. It's all sort of wrinkled and bent. So something happened, whether the lander actually didn't separate properly from the center or upper stage, whether they collided. We don't know what happened, but something is very wrong, resulting in a massive fuel leak. And if you can see that sort of, I'm not quite sure what it is. It looks like part of the landing leg going across diagonally. Yeah. It looks like there's a big dent in it, a big crease in it. So some sort of major anomaly happened. And this is such a shame, because we were all looking forward so much to seeing NASA put something, with the help of astrobotics, put something on the moon. After
was that a South Pole target?
No.
It was going to the edge of Mare Imbrium, near a feature called what was it, Daz? The something dome?
The Gruthansen domes or something like that?
Something like that, which is a geologically very, very interesting area. It's basically a huge flat lava plain at the edge of these domes. Mexico had 5 tiny robots that were going to be literally catapulted off the lander onto the lunar surface. There was another company which was going to put the DNA of some famous people into a permanent solar orbit as another payload, including.
I think that's still happening, Andy, because that's on board the Centaur stage.
Oh, right, that's on board the Centaur. Right.
Yeah, they did a third engine ignition to push itself into that orbit, so that will still be there.
Oh, my mistake. I assume that was on the lander, but
I think initially it was supposed to be on the lander. Yeah, but like we were talking about yesterday, some indigenous tribes of North America, the Navajos,
yes,
have complained, saying that it'd be disrespectful to put people's ashes on there, because for them the moon is sacred. So
right.
Not that they didn't have enough time to mention that before. But,
okay. So there we are. So that's the situation. A big shame. But the good news is the Vulcan Centaur, as a brand new launcher, worked perfectly. So this is good news for the United Launch Alliance. Okay. Another thing, December the 30th, Juno, NASA's Juno probe, which, as you may know, is orbiting Jupiter and has completed its primary mission of trying to figure out what's inside Jupiter. Passed by the moon Io, flew by the moon Io, and this is an amazing image of the Ionian, if you want to call it that, volcanoes. Look at the shadows there of those volcanoes. Absolutely stunning image. Not true color, of course. And you'll also notice quite nicely that the night side of Io is slightly illuminated. That's Jupiter shine. That's sunlight reflecting off Jupiter back onto the surface of the moon. The same way that you can see Earth shine reflected onto the moon. When the moon is a crescent, you can, if you're in a dark place, you can quite often see the dim glow of the night side of the moon that's illuminated by sunlight reflected off the Earth. So this is Jupiter shine rather than Earth shine. And here's another image, a black and white image, which again brings out the contrast and the relief really well. And this is another one from Juno, which you can see the big dark splodge towards the upper right. That's a lava lake, and surrounding a volcano. This is, of course, the most geologically active world in the solar system. It's got something in the region of 220 active volcanoes, and you see some of them here. And it's been called the flying pizza and lots of other things, but it's a fascinating world. It really is. And just to finish off this section, here's an image that Juno took of Io in last October, which gives you a bit more idea of the color. We'll be coming back to planetary colours a bit later, because they've been in the news this
Yeah.
week as well. So there we are. So this was Juno's latest flyby of Io. I think it's its closest flyby so far, and there's another one coming up later in the year.
Yeah, there's another one in February.
Oh, it's as soon as that, is it?
Yeah, there was a flyby on the 27th of December. There's another one in February.
Right,
But it's due to do 3 or 4 more,
right.
because it's slingshotting around Jupiter and other planets to, because this is its second mission. Remember, it's been extended. So
Yes,
yes,
primary
fantastic.
mission's over.
Getting our money's worth here.
Absolutely. I should point out that the bright dots you see in this image are not stars. They are either particles of dust on the camera or other artifacts.
Could
So
they
there
be
we are.
volcanoes actually erupting? Because I have seen images like this where you got the termination line, and they highlighted where the volcanoes were. So it's
Yes.
virtually active all the time. So they could be lights from volcanoes.
Could well be.
Mm.
And don't forget that it was the junior NASA engineer Linda Morabito who discovered the active volcanoes in Io, the first person to ever discover active volcanoes beyond the Earth from the Voyager images. And in quite a few of the images now that have been taken by various probes, you can see on the limb of Io those plumes from erupting volcanoes. Absolutely incredible little world. Of course, all that volcanism is driven by the crust of Io being stretched and squeezed by Jupiter's immense gravity. So that activity is not going to stop at all. It's just going to carry on forever, basically. Okay, moving on. While we're talking about Jupiter, this is an image I hadn't seen before that I found this week. A almost perfect cyclone on Jupiter taken by Juno.
Wow.
And this is a lovely image. I wouldn't like to guess at the size of that, but it's obviously thousands of miles across. So that's just one to finish off the section about Jupiter and Io with. Let's talk about planetary colours. You may be familiar with this lovely image from Voyager in 1989 of Neptune, and everybody was amazed at the deep blue colour of this world. Right in the middle of it, there's what became known as the Great Dark Spot, which was actually an active storm when Voyager flew by it. And this image has become a classic. In fact, it's this image that has led my daughter to say that Neptune is her favourite planet in the solar system because of its lovely colour, which sets it apart. Well, it turns out this week that, in fact, the colour's not correct. And just as a comparison with Uranus and Neptune, here's the colour of Uranus, which is, I always describe Uranus as the solar system's most boring planet. Mm-hmm. And when Herschel actually discovered it, he actually thought it was a comet because it was completely featureless, and he thought that a planet couldn't be featureless because they didn't really know about how gas giants work then.
And when I was out at JPL in 1986, I think that was Uranus encounter, and we're getting closer and closer, and the narrow angle cameras taking pictures. We wonder what is Uranus going to look like after the amazing pictures of Jupiter and Saturn. It was such a disappointment.
Yeah,
and it was thought that there's no structure in that atmosphere until someone got the bright idea to stretch the image. And when that's done, you can see the very subtle atmospheric features. But it was a bit of a disappointment.
Well, I tell you something. At the time, NASA said they were going to make photos of Uranus available after the encounter. And I wrote to them and asked them to send me some. And I was really looking forward to them. And that's what I got back. And I thought, gee, that's really exciting, isn't it? But NASA were great. I mean, if you write to NASA and ask them for things like that, they will send it to you for nothing. They're fantastic. I've still got a book of 50 astronaut biographies that they sent me in about 1968 because I wrote to them and said, "Have you got anything about astronauts?" And they sent me a whole load of stuff. So it's brilliant. You could just ask and they'll send it to you. It's wonderful. They're a wonderful organization. So this is, anyway, getting back to this. So this is what we've come used to as the difference in colour between Neptune and Uranus. It's transpired this week that original deep blue image of Neptune was actually false colour to bring out the features in its atmosphere. They'd actually enhanced the atmosphere and as a byproduct turned it blue. And that's not the colour of Neptune at all. In fact, that's the colour of Neptune.
What?
Yeah.
Yep.
And as you can see, it's very, very similar to Uranus.
Uranus, yeah.
So,
How did that happen then?
well, nobody really knows at the moment. It's just a question that they've enhanced the original image to bring out features in Neptune's atmosphere, and somehow that became the unquestioned standard image of Neptune, and it's been reevaluated and reprocessed, and this is now the official colour.
And how long has it been?
Since 1989.
I know.
Yeah.
Yeah.
So really,
a lot. I'm going to say there's quite a few people who actually do visual and see it as a more of a blue color, but then that's probably atmospheric effects through the Earth's atmosphere, I guess.
Unconscious
That makes it blue.
Yeah.
It's like the original Viking pictures from Mars, wasn't it?
Yes,
they
that's right.
processed the wrong color, but then it was only a few days later when they actually processed them to the correct color.
Yeah.
So why is it taking so long this time to process?
I know.
So it looks to me a lot like a planetary atmosphere that has, you guys call it methane.
We do.
Absorbing
correctly.
red light, but somehow obscured by some photochemical haze or something.
Yeah, that's right. That's right. So there we are. So a bit of a disappointment, and my daughter's absolutely gutted. She hates Neptune now. I don't think it's her favourite planet any longer. So there you are. Moving on. Congratulations to NASA's Ingenuity for completing its 70th flight on Mars. This little helicopter has now completed 70 flights when it was originally thought it would only last for about 5. But in its recent milestone, it flew 260 meters in only 132 seconds, just over 2 minutes. So this is an amazing piece of engineering that just keeps going and keeps going and keeps going. And it's doing valuable work on Mars, acting as a reconnaissance for the Perseverance rover to scout ahead to see the best route to take for the rover, and doing some great science. So congratulations to NASA for an amazing little vehicle. And we hope that we can soon celebrate the 100th flight of Ingenuity. So there you are. So that was in the news. Yeah. The Japanese X-ray telescope XRISM, which apparently is pronounced XRISM, Japanese released its first image from this new wonderful X-ray telescope this week, and it's of supernova remnant X132d. And the interesting thing about this is that they've analysed it spectrographically. And here's what they found in this supernova remnant: a strong presence of sulfur, silicon, but also argon, calcium, and iron as well. So congratulations to Japan for this new telescope, and I'm sure we will see lots of fantastic science coming out of it. Congratulations as well to India. Their Aditya L1 solar observatory has reached its observing position at Lagrange Point 1, which is where the James Webb Space Telescope is, among others. And it's been successfully inserted there and is going to start observing the sun very, very soon. So congratulations to India for another fantastic mission. And that is the news for this week. So
it's fantastic.
So there we are. So some really good stories this week.
Yeah, because with that XRISM, the Japanese XRISM telescope, that was launched the same time as the Japanese SLIM lunar lander.
That's right.
To land on the moon. I'm sure it's the 28th of this month.
It is. We're meant to be the 28th of this month. That's right. So we look forward to that. And if we can cover that live, if it doesn't happen in the middle of the night, of course we will cover it here on Space Oddities if we can. And we do like to bring you live coverage of events to give you our particular slant on it, if you like. And it'd be lovely to have you along. So 28th of this month, the SLIM lander from Japan landing on the moon. And we will tell you a bit more about that mission as we get nearer the landing date. Okay, and so let's move on. Just before we do, we'd like to thank you all for your continued support in buying us coffees, and your coffees do help to go towards keeping this channel running. So thank you very much indeed. If you would like to buy us a coffee, it's simplicity itself. You scan the QR code here, and the details are also in the description of this video. But you can scan the code here to buy us a coffee, and anything you could spare to help support the channel would be much appreciated. And there you are. Don't forget that our Space Oddities merchandise is still available, and the full details of how to get your Space Oddities T-shirts and Space Oddities hoodies are in the description of this video. Be the first on your block to amaze your neighbours with the Space Oddities T-shirts and hoodies. So thank you very much for that. And again, your support is much appreciated. We will be, as we've said last week, we will be having to implement a price rise on the merchandise very soon because our supplier has increased their costs to us, but it will only be a small rise. But buy now at the old price. And we will probably put the prices up, I should think, within the next week. So
Get them while you can. There's a
get them
sale
while
on.
you can at the lower price, and amaze everybody with how cool you look wearing your Space Oddities merchandise. So there we are. So that's that. And what we're going to do now is move on to Lou. And Lou, you're going to talk to us this evening about something called angular resolution, I believe.
Yeah, I'm excited to find out what that's about. So let's see what we...
I can't see your presentation up here, though.
Oh, it's not up yet. Oh, yes.
Aha.
I'm sorry. It is not up. I have not done my due diligence.
Oh, you haven't done your homework.
That's right. That's right.
Oh,
Well, let's see.
There's always one, isn't there? There's always one.
The same one.
The same one. Okay. Right. While we're waiting for Lou to do that,
I'm going to switch the order here and just give me a moment.
Yeah,
Sorry,
certainly. Just to give you advance warning or notice, next week on Space Oddities, we are very thrilled to be joined by Dr. Frank Prendergast, who is an expert on archaeoastronomy, particularly with relation to the Neolithic sites in Ireland. And Frank will be delivering a couple of presentations for us about the subject of archaeoastronomy, as I said, particularly in Ireland. He's a very, very interesting speaker. We're sure you're going to love him. I saw him speak at the County Mayo Dark Sky Festival, where I was before Christmas, and he's a great presenter. So he'll be live here in the studio with us next Tuesday, the 16th, on Space Oddities. Coming up a bit later in the month, we've yet to finalise the date, but we also have Dr. Niall Smith, who will be talking about the subject of bioforming. And if you don't know what bioforming is, then tune in to find out. And again, a very interesting speaker and presenter who we think you're going to love as well. And that's coming up probably towards the end of this month, but we will let you have the date and put it on the Facebook page as soon as we have it. Don't forget to keep an eye on our Facebook group. You can find it by going to Facebook and searching for Space Oddities. I think it's the first one you will find. And by joining the group, it will allow you to keep up to date with everything that we're doing on the channel. And there's a lot of posts there every day. There's something like 1,500 members of the Facebook group for Space Oddities. And they're a great bunch, and they post lots of interesting things. So do join the Facebook group if you haven't already. And that's it. Anything else coming up that we ought to know about?
Just one thing, Andy. Since we've shown the gallery, there's been really interesting conversation going on in the chat. But one thing, I can't let it go.
What's that?
Rachel, you threw a dart and it stuck in your own arm. How did that happen?
I don't know. This is how bad my aim is. Johnny laughs all the time, but I was doing it and it ended up, I don't even know, it ended up in my own arm.
Oh,
were you in the darts match at the time?
Yeah.
No, we're just
because that would have been embarrassing.
But yeah, I'm good at other things. I was like good at basketball and things, but that sort of thing, I don't know.
Well, Rachel, don't ask me to play darts either.
Yeah, so we'll cancel Rachel out of our darts team then.
Yeah, and
Either that or we'll all
In
wear
my
armor.
bedroom, I've once managed to fall over and land and get trapped in a suitcase.
oh, right.
Where Johnny just came up and found me sobbing on the floor, trapped in the suitcase.
Great.
So
Oh,
I'm a
dear,
little bit
anyway.
clumsy and not good at darts.
Right. Okay. Lou, are you having problems?
You guys are doing a great job in at creating filler, and I don't have it up quite yet. So just
Seasoned broadcasters, mate.
chat
Yeah.
amongst yourselves. Chat,
Okay.
chat.
Well,
I
think
just
what
had
we'll
to
do then,
look at Dave
if you may-
Garside said it was double mole.
in one. A lovely lady.
With a hole in her arm, yeah.
Nothing in this game for two in a bed. So there we are. Now, what I think we'll do is we'll put you back a bit, Lou, till near the end of the program, if we may.
Good idea. Good idea.
Okay. So we're going to move on to the subject of planetary defense now. But before we do that, Daz, if you're ready,
Yeah, I
is
certainly am.
going to talk to us about NEOs, which are near-Earth objects. So take it away, Daz.
Well, it's NEOs and NEAs, which is near Earth asteroids. Now, well, this is basically what Andy's going to be talking about is how we're forming a defense against these objects if they're going to threaten Earth, because these things, they come in, especially the ones that come in from outside the solar system. Sometimes we don't detect them, especially if they come from the sun side, until the very last minute. And if you remember, Oumuamua wasn't actually detected until it had actually flown past Earth and was on its way out of the solar system. So we really must be vigilant and be aware of what's actually happening around us. Now, what I'm just going to basically talk about is it's only going to be a quick thing. I only set this up but if you look at this image here, you will see we've got the sun in the middle. We have several orbits around it. The blue planet is Earth, but you'll see the pink circle is highlighted Apollos. The red circle is Athens, and the orange circle is Amors. There is a third category, which is attires, but we'll go through that as I just nip through it. So basically, so what I'll do is next one. Now this is now these are, I haven't labelled them. Oh dear me, this is going to be interesting. Now these are Amor asteroids, and they orbit out to Mars, but they actually do come quite close to us, and they almost cross the Earth's orbit. The two beige blotches are Mars's, because if you remember, we've got Lucy going out to Jupiter, and it'll be visiting the Greek and the other camp. I can't remember what it is now. But this is L4 and L5, and this is a Trojan and Greek camps, and this is Mars's Trojans and Greek asteroids. But as you can see, all these asteroids are out in the green line is a green orbit is the asteroids that go out towards Mars, but they do tend to come a little bit close to our orbit, and this is what we're looking for. We're looking for asteroids that are going to cross our orbit, because this is when they become a potentially hazardous object. So next we have, so now what we have here, these are the Apollos. Now these are the most dangerous, if you would like to put it that way. They're, like I said, they're called potentially hazardous objects. These all circle around, as you can see, they're circling around the Earth, but these will actually, like I say, most of these will actually cross the Earth's, but they're within Mars's orbit, but these will potentially keep crossing the Earth's orbit, and these are the ones we've really got to keep an eye on. So the next one is, sorry, I'm ticking these off because I've, like I said, I've forgotten to think. Oh, sorry, no, these are the Apollos. The other ones were the Athens, which orbit within and outside the. So these are the Apollos. They orbit inside the Earth's orbit, but as you can see, quite often, again, they come out and they cross the Earth's orbit, again, becoming a potential hazard. We have been looking at these, watching these for ages, but because also these orbits of these asteroids can be changed by like Venus, Mars, and things like that. A bit of a tug. They will change, and they will also move between the categories. As I said, the two potential hazardous ones are the Athens and the Apollos, because these are potentially very dangerous asteroids, as they will be crossing the our orbits on many occasions. And the final grouping that we'll talk about just for the minute, and these are the attires, and these orbit inside Earth's orbit, but some of them do come close, but they don't actually cross. But as I said, at any time they can actually get perturbed, and they could come out and cross us. And this is what we've got to be watching all the time. Now, around the world, there are groups that are called. Well, I mean, in the UK, we've got Space Guard. And in fact, just down the road from me at Knightley, we've got one of their observation observatories, and they're constantly watching these asteroids, looking for new ones, and they're basically on alert 24/7, just making sure that nothing's coming our way. Now, one thing you're probably going to ask me, and I haven't got a clue what it is we've got Venus there, but if you notice, there's a circle, an orbit with inside, and they've put it as an H. I've gone through all the literature that came with these images, and I could not find what H was. So if anybody's got any ideas, please let us know. But this is what these are the sort of things we're looking at. Now, of course, some of these asteroids, they travel some long distances, and they come back to us on a regular basis, but over years. And of course, one of them is Apophis, because and that's where Osiris Rex is now on its second mission. Is going out to Apophis, and it'll get there in about 2026, I think it will. 2025, sorry. Now that's one that comes fairly close to us. There's another one called 3200 Pantheon, and again that's one that comes back. But also these objects will create debris clouds as well as they pass by, and it's Pantheon who's thought to be responsible for the Geminids that we see in December. So these things, as well as because we always thought that these were solid things, but of course with Osiris Rex and the Rygu, we've looked at these things, and a lot of them are just piles of rubble. And this is something that probably Andy's going to talk about. There's only one other thing I would like to talk about, is that some of the things that we are tracking are man-made. J002E3 has been spotted, and at first they didn't realize exactly what it was, but they knew it wasn't actually an asteroid. And it turns out, with further analysis, that using spectroscopy, that it is actually the booster stage of an Apollo mission. And it's been around the sun. Apollo 12 it was. It's been around the sun, and it's on its way back in. So we've also got to be tracing things like this. And also 2018 AV2 is believed to be Snoopy, which was the Apollo 10 lunar lander, which is coming back towards us again. It's been all the way around the sun when it was discarded from Apollo 10. So that's basically what we're looking at. We're looking at these asteroids, some of them that we're going to cross our Earth path. And of course, the most potential hazardous ones are the Apollo asteroids and the Atens. There is a lot more detail that goes into them. I'm not going to bore you because I don't understand some of the mathematics and the orbital dimensions of these things, but that's what we're going to be looking at. So back to you, Andy.
Thank you very much, Daz. Very interesting. There have been quite a few suggestions in the chat as to what the H is. I thought it was simply the planet Hercury, but apparently not. Andrew says the chemical symbol for Mercury is Hg, so I presume it's been shortened to H because there's already an M there for Mars. And Alan says simply H is for Hermes, which is the Greek for Mercury.
Oh, okay then.
It's quite obviously Mercury on that diagram.
Yeah, of course, yeah.
It has to be Mercury.
Yeah,
so there we are.
that's what I was thinking, but I couldn't
suggestions.
understand. Yeah, of course, I suppose. Yeah, H is the chemical symbol. Hg. Yeah. Oh,
yeah. So there we are. So what we're going to do now, following on from this theme of near Earth objects, I'm going to talk a little bit about the threats to our planet. So we're probably all aware that throughout recorded history, and even before recorded history, throughout its history, the Earth has been bombarded by space rocks, ranging in size, of course, from the sort of the grain of sand size that we see shooting across the night sky as meteors to much larger objects. So just give me 1 second to set this up, and here we go. And when we talk about larger objects, there have been many famous examples of these. One of the most famous, if not the most famous, of course, is the Arizona meteor crater, formed, it is reckoned, about 8,000 years ago by a meteor that was an iron object that struck the Earth at maybe only about 50 feet across. No remnant of it has ever been found, so presumably it was vaporized in the blast. But that's the famous Arizona meteor crater. Much more recently, in 1908, we had what's referred to as the Tunguska event, where hundreds of square miles of trees were flattened by an object that exploded above Tunguska in Siberia, a very, very remote region of Siberia. So remote, in fact, that it wasn't until 1927 that an expedition was mounted to go and see exactly what had happened. There were eyewitness reports of a huge fire in the sky. And we think there was possibly one death associated with this when somebody was blown into a tree, or into the trunk of a tree, I should say. But this was, this was potentially disastrous. We don't know the size of the object. No remnant of the object itself has ever been found because it's assumed that it vaporized when it exploded in midair. The jury, I think, is still out on whether it was an asteroid, a stony asteroid, or the nucleus of a small comet. We really don't know, and there are sort of contradictory bits of evidence one way or the other. We may never know exactly what exploded above the ground in Siberia in 1908, but you can see the devastation it caused. If the Earth had been slightly more rotated, it could have hit a city, and this is always the danger. And in fact, that nearly happened in 2013, again in Russia, at a city called Chelyabinsk, where a huge, a comparatively huge object, about the size of a London double-decker bus, streaked through the atmosphere above Chelyabinsk and exploded. And you can see here the event itself, which was recorded by many people, particularly from dashcam cameras, which the Russians seem to like having. And there was quite a lot of damage from the explosion. About 1,000 people were injured in this detonation, mainly through being cut by flying glass. But here you can see somebody literally being blown off their feet by the blast. And this was a complete shock. Quite a few large fragments of this object were recovered, particularly from a lake where it had actually just sort of gone straight through the ice on top of the lake. But this was a fairly major event, and it did make us realize that this could happen at any time. So this was only 10 years ago, just over 10 years ago. So the statistics of an event like the Tunguska event are reckoned to be can happen in about once every 100 years. But, in just about that time, we had this event in Chelyabinsk. And we've learned quite a lot about the object, but, with 1,000 people injured, it just emphasized just how dangerous these objects are and how lucky we often are that there aren't more casualties. So there is a global network of so-called planetary defense to try and find these objects and chart them and to give us early warnings of any that are coming our way. Daz mentioned Apophis in his presentation, which has a small but finite possibility of striking the Earth at some point in the future. It's making a close approach to the Earth on 2029, and it's not thought to pose us any danger in 2029, but sometime after that it could. We've also got Bennu, which is the most dangerous asteroid in the solar system that OSIRIS-REx recently returned samples of, and that's got a really good chance of hitting the Earth at some point in the future. This is a map of the last 20 years of mapping these near-Earth objects, and there are about 18,000 objects that have been discovered so far. We don't know about them all. The thing was about the Chelyabinsk object that it was completely out of the blue, no pun intended, and we didn't know it was there. And if they come from the direction of the sun, it makes them incredibly hard to spot. But this is a graphic from NASA showing 20 years of studying these objects and what we've discovered. When you look up into the night sky and you think, there's nothing out there between us and the planets or us and the stars, this shows that space is far from empty. So this makes you realize that we are in a cosmic shooting gallery, and collisions inevitably will happen, as they have happened on all the other planets. You may remember Comet Shoemaker-Levy 9 ploughing into Jupiter in the 1990s, leaving those massive scars in Jupiter's atmosphere for a few weeks. And when we look at other planets in the solar system, we see countless examples of impacts, both large and small, and the moon, of course. So impacts can and will happen to the Earth. And it's not a question of if the Earth gets hit by a large object, it's a question of when. So planetary defense is really, really important. We don't want to see something like this. We don't want to see another dinosaur extinction level explosion. And so the question is, what can we do about it realistically? Let's have a look at the hazards by the numbers. Now, if you look at on the bottom, we've got things that look like pie charts. Well, these are pie charts showing an estimation of what percentage of which type of object has so far been discovered. The ones smaller than 10 meters in size, only 0.03% have been discovered. And these are estimated to hit the Earth about once per decade. These can cause damage. These were sort of the type of object that the Chelyabinsk object was. And a very bright fireball, strong sonic boom could break windows. Well, as we saw in Chelyabinsk, it did break a lot of windows and hurt a lot of people. The 50 meter up to 140 meter size, we've only discovered 7% of them for the 50 meter size, and only about 40% of the up to 140 meter size. And although these impacts are statistically going to happen once every 1,000 years in the case of the 50 meter objects, and once every 20,000 years with 140 meter objects, they are still a danger. These are the dangerous objects that we don't know that much about, and we haven't found that many of, but we have good reason to believe there are a lot more out there that we haven't discovered. And of course, it goes up to the 1,000 meter objects and the 10,000 meter objects, which are going to be incredibly rare, once per 100 million years. And this is a life extinction event. Now, over the last couple of decades, the call has been growing and growing for countries to spend more on early warning and identification for these objects. And it's a good sign that over the last few years, if we look at NASA in particular, their budget for identifying near Earth objects has grown. And I just want to show you the figures of that. We've got two colors here. We've got the observations of the near Earth objects and DART, which was the NASA mission to actually try a solution for dealing with these objects. I'll talk more about DART in a moment. But as you can see, the expenditure has risen quite a lot over the last few years as the clamour to actually do something about this danger has grown and grown and grown. Now, obviously, a lot of money still needs to be spent, not just by NASA, but worldwide, in protecting our planet against these objects that could cause disaster without warning at any time. How would we deal with the threat, assuming we've identified an asteroid that is in danger of striking the Earth and causing a problematic event, if you want to put it like that? What could we actually do about it? Well, the first and most obvious option is just to nuke it. And that may seem an elegant and simple solution, an effective solution, but in practice, it's really, really not. The reason is that many asteroids are not solid objects. They are bodies of loose rubble held together by gravity. Asteroid Bennu, currently considered the most dangerous asteroid in the solar system as far as the Earth goes, is an example of this. And here is a picture of Bennu, and it is literally just a pile of rubble. It's not solid by any means. And if you nuke something like this, you risk the danger of splitting it into countless objects, the ones that aren't vaporized. And you only need one of those fragments of the asteroid to hit the Earth, and you haven't solved the problem. You've got a disaster on your hands. So trying to nuke an asteroid and making sure that every last bit of it is vaporized and there are no fragments flying off that are going to hit the Earth is a bit of a dangerous business, and there are too many variables for it to be considered an effective option. If the asteroid is solid, like an iron meteorite, for example, or an iron asteroid, or even a solid rocky one, if that is the composition, it might work. But the problem with all of this, we need to know the composition of the asteroid in advance. Another option, which has been suggested, is simply to tie rocket engines onto the asteroid and push it away. Well, this is A, not extremely cost effective, and B, it's not really reliable either. You might end up deflecting the asteroid further towards the Earth than it was originally. So although this has been proposed as a solution, it's not a particularly good one. Another option is the so-called gravity tractor. Now, this consists of a spacecraft which orbits the object, and simply by the gravitational field of that spacecraft, over time, it would deflect the asteroid from its course enough to make it miss the Earth. And this is called a gravity tractor. Now, theoretically on paper, this works. It's obviously never been tried. But the problem is that you would have to have that spacecraft in orbit around the asteroid for probably months before it would have the effect of deflecting it so that it doesn't hit the Earth. And we may not have months to act with these asteroids. Another option, which has been suggested, which on paper works, is to spray paint the asteroid, spray painting it white so that the sun's pressure reflected off the asteroid, reflected off the paint, would be enough to push it slightly and deflect it away from the Earth. This is how a solar sail works. It uses radiation pressure reflected off the solar sail to move a spacecraft. And the idea is that if you spray painted the entire asteroid with say, brilliant white, the reaction from the photons bouncing off it would be enough to move its path. But again, this would probably take a long time, and you may not have that time. The final solution is known as a kinetic impactor. It's, apart from the nuke, it's probably the most direct solution, and that is to slam a spacecraft into the asteroid to give it a kick to push it away from its dangerous trajectory towards the Earth. And in fact, this has been tried with the NASA DART mission, the Double Asteroid Redirection Test. And this mission had a very simple concept. The target was chosen as a double asteroid system, a binary asteroid consisting of two asteroids called Didymos and Dimorphos, which are both rubble piles. That is to say, as I said earlier, not solid objects, just held together by the mutual gravitational attraction of all their bits of rubble. And NASA came up with the idea of slamming the kinetic impactor, in this case the DART spacecraft, into Dimorphos, the smaller of the two, which orbits Didymos, to see whether its orbit could be affected by simply slamming a spacecraft into it. It was a very brave and audacious mission, but it was worth trying because we do have to try these solutions. And this happened 6.8 million miles from the Earth. Now, the comparative mass of the two is quite different. The spacecraft, at the time it arrived at the system, having expended most of its fuel, had a mass of 580 kilograms. And the asteroid, Dimorphos, is estimated to have a mass of 5 billion kilograms. So the question is, how could you slam a spacecraft with a mass of only 580 kilograms into an asteroid with a mass of 5 billion kilograms and deflect its orbit, change its orbit around Didymos? Well, the relative speed of these two objects would obviously need to be quite high for it to have any effect. And in fact, the spacecraft did slam into Dimorphos at an impact speed of 4 miles per second, or 6.6 kilometers per second. And if you just want to get an idea of how big that asteroid is, here it is compared to Rome's Colosseum. It's a big rock. Now, this was the launch of DART in 2021. In November 2021, this launched. And it was a perfect launch, a perfect mission. The spacecraft was sent on its way. And this is an image of the asteroid in question, just showing just what a pile of rubble it is, with no real solid surface. It's all made up of just bits of rubble right the way through, not just on its surface, but the whole asteroid is like this, just bits of rock held together by their mutual gravitational attraction. Now, here's the actual last moments of the spacecraft, the 5 minutes leading up to the impact. This is a time lapse, so it's speeded up a bit. As you can see, we've got Didymos coming into the foreground now, and you can see that is indeed looks like just a pile of rubble, the same as Dimorphos. We're now approaching Dimorphos at that speed of 4 miles per second, and it's quite obvious that this is a pile of rubble. And these are the last moments of the spacecraft as it slams into the asteroid. That's the last frame. The next frame was not completed because the spacecraft had died, slammed into the asteroid. And this was witnessed from the Earth, from France. And you can see this is on a loop, but you can see the impact observed from the ground and a cloud of debris flying off the asteroid. These are two images of the impact from the Hubble Space Telescope and the James Webb Space Telescope in visible light and in the infrared. Quite a spectacular detonation. In fact, much more spectacular than I think anybody had thought it would be. And did it work? Well, the answer is yes, it did. The orbit of Dimorphos was around Didymos changed. And you can see here that the blue line represents its original orbit and the yellow circle represents its new orbit. It did change quite significantly. And in fact, its orbit around Didymos was shortened by 32 minutes. More than 1,000 tons of material were thought to have been ejected in this explosion. So we have, for the first time, changed the orbit of an asteroid around its parent body. This has demonstrated that the kinetic impactor idea works. And it was a very successful mission, so well done to NASA. On the back of this, NASA have come up with a plan for the future for dealing with these dangerous objects. I won't go through it in detail, but it's basically expanding the observing network to continuously monitor the skies, developing advanced radar and optical systems for precise measurements of these objects, using space-based missions like NEO-Surveyor to increase the detection rate of these objects. NEO-Surveyor is a dedicated spacecraft for finding near-Earth objects that is going to be launched in 2028. Then we've got developing and testing the new technologies, using or exploring various deflection techniques, including the ones I've talked about. Additional test missions to repeat the DART mission in a different way with a different asteroid, and getting countries to work together on this threat that does threaten the entire Earth, and sharing the expertise and the knowledge that organizations like NASA have gained. And preparing for those potential impacts, you need mitigation plans, you need strategies for dealing with things like mass evacuations, public education and outreach, which of course we at Space Oddities are all in favor of, and international coordination and cooperation. And the summary of all this is there are solutions which can be used to divert the trajectory of these threatening objects, but a lot really does rest on knowing about the objects in advance, knowing what they're made of, knowing what their mass is, and coming up with an appropriate strategy. There's no one solution for this problem of threatening asteroids that's going to work for every single one that threatens us, because each asteroid in its way is going to be different. So we need a range of strategies that we can apply the correct solution to a particular threat in the future. And of course, we need globally to spend a lot more money on planetary defense. So there you have it. That's
Andy, can I just pop this? I did have another slide.
okay.
Now I know this is out of date because you can see it's, but this is boloid events, as they say, which were asteroids or meteorites that disintegrated in Earth's atmosphere, and this does include Chelyabinsk in it. And this just goes to show, in this period of just under 10 years, this is how many were reported. And you can see the represented in the sizes along the bottom, and also the ones that were seen during the day and during the night.
Yeah.
So as you can see, that was just in 10 years of these things that actually came through the Earth. And
I see it's looking at that. I mean, it's almost evenly split between daytime event and nighttime event.
Exactly. They're coming at us all the time. And this is what we need to know. And these have all been, it's luckily small enough not to have caused much damage.
Yeah.
The Tunguska I've done it again. Tunguska event was the equivalent of 10 megatons because it was an airburst, it is thought. Like I said, as you said, they think these sort of events had 2,000 to 3,000 years, to one event every 300 years. The second largest event after Tunguska was a megaton air blast, at 1.1 megaton air blast in 1963 near Prince Edward Island between South Africa and the Antarctic. It was detected only by infrared sound sensors. However, this may not have been a meteor. Now, this is what I'm saying. The only reason we know about this event, it was detected by sensors. It wasn't actually seen. So, like I said, that image I put up of those 10 airbursts or fireballs that have been reported, that is probably just the tip of the iceberg. Sure. And the third largest was the Chelyabinsk on the 15th of February 2013. And as you said, a lot of people, that was sort of like a yield of 400 to 500 kilotons. And of course, like you said, most of the injuries were by broken glass because people saw the fireball move to the windows, and then of course the shock wave hit a bit afterwards. But this is just why we need to be aware, and why we need to try and find ways of mitigating these things. And I'd just like to pop this up from Anne. She said, we saw a huge fireball going up the Irish Sea in 1969. It landed in in Northern Ireland, partially in a field, and part went through the roof of a police store shed. It's
Wow.
on display in the Mar Planetarium. So
Wow.
that was Anne. Thanks for that, Anne. That sparked off a whole
Thanks,
load
Anne.
of new chat in the chat. So yeah,
Great. Fantastic. Thanks, Anne. I would like to have seen that. I've only seen, I've seen, a good few good fireballs in my time, but nothing's ever impacted, as far as I know. So, well, they all impact somewhere. But a lot of them go in the sea, of course, and we don't get to know about them. So there you are. So that's just a little thing from us tonight about planetary defense. The bottom line is the world needs to spend more money on this.
yeah,
And especially governments need to take the threat a lot more seriously than they do. It's not a priority for most governments for fairly obvious reasons, but we could have a disastrous event happening without warning.
I mean, as regards to warnings and all that, if the governments know about it, but they don't want us to know about it, just keep an eye on the sales of hard hats.
Yeah,
because the government will all be buying hard
that's
hats.
right.
So yeah,
And look for elections being called.
yeah.
before the event, snap elections. So there you are. Okay, Lou, are you okay now? Yes, it looks like you're there.
I think we're good.
Okay.
Good. Just two quick comments about all of this. The first is the accurate graphic that you showed with the near-Earth objects in orbit that looked like it was jam-packed, which it was, thousands of objects. That is what it looks like when it fits on your screen. But if you could look at the actual size out in space, you could look anywhere you wanted, and the odds of seeing any one of them would be almost zero.
Of course,
because the space is so large. The other is that for the map of bolides that Daz, that you showed, remember that a bolide that can light up the night sky might be as small as the tip of your little pinky. Okay. Most of the meteor showers that we get are grains of sand size, that kind of thing. So a bolide could be anything from that to something much bigger. Just
to pick up on one of those, Lou, when you see films like Star Wars, where they show spacecraft flying through asteroid fields where the asteroids are almost touching each other. Of course, if you were to fly around the asteroid belt in our solar system, if you were standing on one of those asteroids, you wouldn't be able to see any of the other asteroids because, as you said, they are all incredibly spread out.
That's right. Yeah.
I'm not saying that there aren't star systems out where there is an asteroid belt where the asteroids are very, very close together, but it's not incredibly likely. So there we are. Yeah. All right then. So Lou, how much can you see is the title of this presentation.
Yes. So I was doing my usual surfing social media, and I came across a question. Can you make out details on Titan with a backyard telescope? I thought about this for a minute, and then I thought about it for another minute. And I thought, well, this might make an interesting project to talk about on Space Oddities. Let's go here. So the question is, what can you see? What kind of resolution can you have when looking at objects in the night sky? And this is just a stellarium image of Saturn and a few of its larger moons. So we see Titan there. Titan has a diameter of about a solid diameter of 5150 kilometers, not that big. And at 1.5 billion kilometers distance, if you do the math, that comes out to about 0.7 arc seconds in size, right? Arc second being 1/3600th of a degree. So pretty small, but you have good backyard telescopes. So what's the deal? Well, we started thinking here. Let's advance here. Now, this is, you all will remember this. On the left side is a Hubble Space Telescope image before the optics were corrected, right? On the right side, a Hubble Space Telescope image after the optics were corrected, after the eyeglasses, as it were, that were developed at Goddard Space Flight Center were applied to the optic train. And so it depends a lot on the quality of the optics that you are using, right? So what we're going to be talking about today are theoretical limits. The best telescope with the best atmospheric conditions and so on, what can you see? What kind of spatial resolution can you hope for in your backyard telescope? And we'll go a little bit beyond the backyard telescope in a moment. Well, it turns out that there is a way to know, again, for this theoretical limit, and it has to do with a very small equation which defines the Rayleigh diffraction limit. And this equation describes an angle, that's the theta on the left, the smallest angle that where you can separate 2 point source objects, say, for example, two stars, maybe a binary star system. So with a very, very small telescope, for example, you might see them as one object together. And with a larger telescope, you might see them as two separate objects. And the equation has a constant in it of 1.22, which comes from the distance between diffraction spikes, I think, for a circular aperture. It's just a number for us. Times the wavelength of light, and that becomes very important, divided by the diameter of the telescope that you're using. And so, of course, you have to keep wavelength and diameter in the same units, and we will do that in just a moment. But it's a very simple equation for figuring out what your chances of being able to see fine detail in the images that you are looking at through your telescope. Well, let's take the Hubble Space Telescope as our example here. We have our equation of theta is 1.22 lambda over d. And if we work this out, we're going to select a wavelength in the visible part of the spectrum, kind of the middle of the visible spectrum for Hubble. Hubble can see into the near infrared, but just for example's sake, of 550 nanometers. And we're going to divide that by 2.4 meters, okay? And we get, you can see 2.8 times 10 to the minus 7th radians, and we convert that into degrees. And then we multiply by 3,600, which is the number of arc seconds in a degree. And the answer is the Hubble out in space with theoretical limits can see about 6 times 10 to the minus 2 arc seconds separation. Pretty good, pretty good. Remember we said that Titan had a angular diameter of 0.7 arc seconds. So you can get some fields of view across Titan with Hubble. Okay. Now, let's go to your backyard telescope. Here's a typical Celestron 8-inch Schmidt-Cassegrain. And we apply the same math to this, and we get an answer, surprisingly, of about 0.7 arc seconds, which just happens to be approximately the diameter of Titan. So you're not going to see too much detail. Of course, Titan in visible light is shrouded by a photochemical haze, so you're not going to see that. But being able to see much more than a point source for Titan is going to be a little problematic with an 8-inch telescope. Well, that's an 8-inch telescope. That's fine. Well, let's get a little bigger here. James Webb Space Telescope, of course, has been in the news, and it is an amazing piece of technology, as is the Hubble Space Telescope. So I wondered, well, what kind of angular resolution can you get from both of these instruments? And so I did 3 calculations here. For the Hubble Space Telescope, the calculation on the far left, I use 550 nanometers, and we get about 0.06 arc seconds. But for James Webb, it has a huge infrared wavelength range, depending on which instrument you're using. So I selected 2. James Webb Space Telescope has a diameter. Its aperture has a diameter of 6.5 meters. And so when we do the math on something that's, say, 600 nanometers in size for wavelength, you get 2.3 times 10 to the minus 2 arc seconds. Not too shabby, not too shabby. So you're going to get some definition across the field when looking at Titan. And remember that because Titan is shrouded in a photochemical haze, which is opaque in visible light, you have to look in these windows, these in between methane absorption features. In the infrared, between 1 and 2 microns, there are 4 windows, I think, where you can peer all the way to the surface. So here we have a chance of actually seeing some surface features with a spatial resolution stated here if we're using 600 nanometers in wavelength. But James Webb has a spectral range that goes all the way up to 28,500 nanometers. And so using the same aperture size, of course, when you do that, you get a angular resolution of more like 1 arc second. So it really makes a difference what wavelength you're using to view in. Why are radio telescopes so large? Well, one reason is we can build them large because radio waves pierce the atmosphere fairly easily. So we can build these things on the ground. But they're also quite large because you have to be able to accommodate very long wavelengths to get some sort of angular resolution. So for the last slide here, I thought, okay, those are numbers. They're interesting for some of us. But what does it really look like? Well, here are 2 images of Titan taken from the, Earth orbit area. At low Earth orbit, we have the Hubble Space Telescope Wide Field Planetary Camera 2 image. And that has a spectral range of 0.85 to 1.05 microns. That's in the near infrared. And it's piercing the cloud decks of Titan. And you can see some visual representations of the surface, perhaps even methane clouds. It's unclear. I should point out that after Voyager flew by Titan, and we had those great images of cloud cover, when we were doing the Cassini planning, this was a lot of the data that we had on the surface of Titan were Hubble Space Telescope images that could see through the haze. And so I remember being at countless planetary science conferences where these images were shown as Titan rotated and saw all sides, and it helped in the design of the Cassini mission. On the other side, we have the James Webb Space Telescope NIRCam, near infrared camera image, which is fairly recent, and it operates in these 2 wavelength regions, 0.6 to 2.3 microns. I'm changing units on you, so I apologize. We were talking nanometers, now we're talking microns, 10 to the minus 6 meters. So between 0.6 and 2.3 microns and 2.4 and 5 microns. Again, able to look through these windows between methane absorption features onto the surface. And you can see here, scattering from atmospheric haze. You can see what is probably a methane cloud in the lower stratosphere. Probably here we're seeing liquid aquifers, the hydrocarbon lakes, if you will, and surface features, this kind of thing. So it's not very high resolution, but it is. It has one great advantage, and that is that we can watch Titan over very long periods of time and see how the atmosphere and perhaps the surface are changing over time, kind of adding to and completing the work that Cassini began. So that's the answer. I think if you want to try to get some resolution on Titan with your backyard telescope, my hat is off to you. Send us your pictures. We will give you a Space Oddities We Are Amazed T-shirt if you get detail on Titan from your telescope. But of course, there's so many other things to see.
Absolutely. Thank you very much for that, Lou. Very interesting. While we're on the subject of angular resolution, one point that moon hoaxers always raise is that why haven't we used things like the Hubble Space Telescope to view the Apollo landing sites on the moon? And as you've just so nicely demonstrated, no telescope on Earth or the Hubble Space Telescope has that angular resolution enough to image small things on the moon like the Apollo landing sites. And if you do talk to any of these idiots, that's really what you should say to them. Not that they ever believe you, of course, because it's all a NASA conspiracy and blah, 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 blah. We've all been there. But we have to try.
I imagine with how bright the moon is from reflected sunlight, it might blow out some of its
that's right. That's
images. Well, I don't think it's designed for things that
you
bright.
wouldn't want to do it in any event, but you know, no Earthbound telescope or no space telescope has the resolution to image Apollo landing stages on the moon, or the you know, I've even heard people saying, why haven't we got photos of the flag on the moon? And you know, from
we do.
We do.
They were taken by the Apollo astronauts.
We have them from well, I don't know about the flag, but we do have images of all of the Apollo landing sites taken by the Lunar Reconnaissance Orbiter from lunar orbit.
Yeah, that's right.
So you know, you can even see the tracks made by the lunar rovers.
Yep.
But you can't see that from the Earth. It's an optical impossibility that we've got any telescope that big. I don't know how big the telescope would need to be. Your calculations would probably demonstrate it, Lou. That's a little bit of homework for you. Come back next week and come back next week and tell us how big an aperture you would need from the Earth to be able to see the Apollo landing sites on the moon. If you would be so kind.
Will do.
That would be interesting. It all gives us ammunition against morons, so I'm all in favour of that.
Don't see any naysayers in the chat.
How short the exposure would be because of the brightness of the moon.
That's right. Right.
That's true. Yeah,
these things. Come on, Lou. You're much better at maths than any of us. I'm sure it's absolutely nothing.
Here's my calculator. Here we go.
I'm sure it's nothing to a man of your mathematical abilities. So that'd be quite interesting to know, so we can give these people actual figures. So there we are. All right, then. We're going to go over now to Michael.
Okay.
Who has something he wants to say to us, I believe.
Yes. I'd like to point out to you all my magazine called Capcom, Spaceflight and Astronomy magazine. Some of you will know what the acronym Capcom stands for. It comes from the old NASA term for capsule communicator, which was the title of the astronauts on the ground that used to communicate with the astronauts in space. Capcom has been published now for more than 30 years. It's published every 2 months, 6 times a year, and we have original articles from published authors. The latest issue for January 2024 is now available. Capcom can be purchased for just £14 per year for 6 issues, printed and delivered to a UK address, or also £10 per year as a PDF copy, sent to any email address around the world. Also, this particular month, we celebrate 30 years of fixing Hubble with the CoStar eyeglasses that Lou mentioned earlier, and also 50 years since the third mission of the astronauts to the Skylab space station. So that's what we got on this month. Also, I'd like to let you know that my local society, the Carolian Astronomy Society in Kidderminster, next meeting is tomorrow, Wednesday, the 10th of January at 7:30 p.m. Our speaker is Dr. René Breton from the Jodrell Bank Centre for Astrophysics, talking about the Space Orchestra, how scientists take data on the star, about vibrations, and turn them into sounds. That's at the King Charles First School in Kidderminster tomorrow night at 7:30. Website is at coroniumastro.co.uk for more information on that.
Great. Thank you very much.
much.
So there we are. Thank you very much for that. Okay, well, we're going to shortly draw things to a close. Obviously, we would like to thank you very much for being with us. We hope you'll join us next week on Tuesday, the 16th of January, when our guest will be Frank Prendergast talking about archaeoastronomy. We're looking forward very much to having Frank join us. We hope you'll join us too. And just a last thing before we close for today, if you would like to buy us a coffee, you can scan the QR code, and your support is much appreciated. And we'll be back next week at the same time. And we'd like to thank you all for being here. And we've had a good crowd in, as we always do tonight.
Yeah, and I'd just like to thank everyone in the chat. It's been quite fun. There's been a lot of hilarity going on and comparing of ages and things like that. So thank you again.
Yes.
Thank you for joining us.
And I will reveal all next week, but I just did some quick calculations, and it looks like a Hubble Space Telescope times 100
really
might be able to image. Might be able to.
Yeah.
Wow, that's amazing.
That the caveat is it, Lou?
Yeah.
It's a big pair of binoculars, isn't it?
Yeah.
Yeah. So there we are. So thank you for doing that, Lou. But we can talk further about that next week, I'm sure.
Talk about it next week.
And we'll all be back next week. Well, Michael, you won't be here next week.
No, I can't do it next week. Sorry,
Michael is unavailable next week.
Yeah.
I shall be here next week, but probably not until about halfway through the show.
Oh.
Who was that?
Is Johnny in the room?
Isaac and I will not be here next week either. It's my Astro Society talk next week.
You didn't throw a dart at a cat by any chance, did you?
This is why I sit on mute.
Oh, look, Johnny's got his suit on.
Hi, hello, Isaac.
Does that mean I get to do a big gallery of my pictures then?
You get to do a gallery next week.
No, what have you done? So
All right with you,
Rachel
Roger.
won't be here next week. But anyway,
I'll be doing pictures of the lunar landing sites then.
Yes.
From Sparkford.
Yeah, of course.
Just fresh off the press, something's just come up. The private Peregrine moon lander won't now be making a landing. I think we'd already sussed that
Well, we
out.
knew that. Yeah.
So that's just
It's
flashing.
very sad. It's very sad. But as the old saying has it, space is
hard.
Yeah, space is hard. So there we are. So we won't see Michael or Rachel next week. Rachel, perhaps you can stay away from sharp objects during the week.
Yeah.
And,
Just the darts.
yeah. And,
We'll try.
magic darts. And it's great, smashing, super. So anyway, from us all at Space Oddities, thank you so much for being here. Keep your eye on the channel, because I will be posting some stuff on the channel this week, and we hope to see you back next week, same time, same channel. So from all of us at Space Oddities, have a fantastic week, everybody. Thanks for your support, and we'll see you all again next week. So from all of us, goodbye.
Thank you.